Good day, everyone. Our lesson for today is all about margin of error and confidence interval when the population sigma is unknown. So the population here is represented, the sigma, the standard deviation, is represented by sigma or this symbol. Okay? And what are we going to do or to solve now is when the population is unknown. So what is the symbol that will represent for this? Okay, kasi in our previous video, when the population is known, so we talk about the Z. So how about now when the population is unknown? But before that, don't forget to like and subscribe to this channel and hit the bell button for more updates. Also, you can find different subjects in this YouTube channel. Just select the playlist section. And finally, please don't skip the ads for this video. Thanks! And now, let's proceed to our lesson. Confidence interval for the population mean when sigma is unknown. In statistics, there is a method that we can use to compute confidence interval for the population mean when sigma is unknown. Sigma is not known, so it must be estimated by S, the sample standard deviation. So since, sabi nga doon sa ating explanation, since sigma is unknown, we will replace it by letter S, which can be read as the sample standard deviation. Now, this means that a multiplier of the standard error of the mean denoted by, so yung standard error, ayan, ng mean ay S over square root of n. N is the number of population or sample population, and S, okay, is the sample standard deviation. And we have T, okay, that is the population mean when sigma is unknown. Okay, this is a T values. And we have here the X. Now we should put X bar there. Okay, that's the X. So the distribution of the values is called the T distribution. Okay, now, the T distribution was formulated in 1908 by an Irish brewing employee named W.S. Gossett. I don't know if that's correct pronunciation. The T distribution, sometimes called a student's T distribution. And it has a what they call this, a confidence interval of the population mean greater than mean or the sample mean minus t quantity s over square root of n, but less than mean, okay, plus, I think this is plus t quantity s over square root of n. Or simply, this can be written also as mean, okay, minus the margin of error, which is represented by capital E, okay, less than the mu, the population mean, okay, yeah, and then less than, or this is greater than mu, but less than mu, so that is x, or the mean, plus the margin of error. So simple as this. This one, therefore, this one is the formula to compute the margin of error. Okay, now another, we will use here the t table. Okay, so I prepared another t table that is very easy to use. This is a Ots-Heckard t table. Okay, that you can download it in Google. So I just downloaded it in Google, okay, so that you can easy to, to understand the t-test table. Okay, as you can see, there is a degree of freedom here. So later on, we will use these degrees of freedom. Okay, now let's continue. All right, so we will use the t-test table for this one, and then, all right, so the t values are based not on sample size n, but on degrees of freedom. So we have a formula for the degrees of freedom, which is n minus 1. Okay, now, example, n equals 20. What is the confidence interval? Okay, we're talking about the confidence coefficient rather, if the confidence interval is 95%. So the first thing to do is to find the DF. So for the DF, we have 19. Paano siya naging 19? Because we have a formula, n minus 1. Our given n is 20 I mean. So 20 minus 1 is 19. And the confidence coefficients is 2.09. Let's check. So we have a degree of freedom, which is 19, and a confidence interval. What is the confidence interval? I forgot. That is 95%, right? So we will look for 95% confidence interval, and then the 19. So what is the intersection of the two? That's 2.09. You got it? Okay. So before we proceed to our next part, okay, or next slide, please download this first. Okay, download this what they call this the table, so that you can you know um, follow our given examples later. Okay, so let's have the continuation for this one. So again, the df has a formula n minus 1, and that is 20 minus 1, so we have 19. And using the confidence interval, which is 95%, so the confidence coefficient is 2.09. So now, um, let's find the following confidence coefficient of each given n. So the n is 6. So the degree of freedom is correct. So degree of freedom is 5. And then it is 90% confidence. Okay? Can you please look for it using your t-test distribution table? So what's your answer? Correct. It's 2.02. How about n equals 7? So the degree of freedom is 6. And then it has 95% confidence interval. So what's your answer? Correct. So that's 2.45. How about n equals 10? So the degree of freedom is 9, and with 99% confidence, that's 3.25. N equals 15. 90% confidence. That's 1.76 because the DF is 14. How about n equals 18? What's the DF? That is 17. With 95% confidence interval, we will have 2.11. N equals 24. With 99% confidence interval, the DF is 23. So we have 2.81. N equals 31 with 90% confidence interval. The DF is 30, so we have 1.70. N equals 11 with DF is 95% confidence. So I mean the 95% confidence interval with the DF of 10. So that is 2.23. Okay, question. What if our given n is, let's say, 45? 45. Okay, so our given f is 45. So if we will look to this, the df is 44, right? So there is no 44 here. We only have 40 and 60. Okay, so what is higher, okay, than 44? Not 40, the answer is 60. So our df, we will use 60 as our base. So it will depend on the given confidence interval now. So if we have, let's say, 95%, so the value for this 60 is 2.00. Okay? So, ganun siya. So, kapag hindi siya sakto o wala siya dun sa dito sa DF, tignan mo yung mas mataas sa kanya. Let's say 60. So, 16, let's say 44. So, 40 is not higher than 44. So, we have 60 as our higher number. Okay? Than 44. Okay? So, let's proceed. Now let's have this problem solving. Alright, so we have this one. Example. An admission officer of an education institution wants to know the mean age of all entering mathematics major. He computed a mean age of 18 years and standard deviation of 1.2 years on a random sample of 25 entering mathematics major purportedly, coming from a normally distributed population. With 99% confidence, find the point estimate and the interval estimate of the population mean. So we're looking for the margin of error, the point estimate, and the interval estimated. So we're talking about the interval. Okay, so to solve this one, first we need to write the given. So the given are the mean, which is 18, standard is 1.2, and the n. The population is 25 entering mathematics major. Okay, we have 99% DF. So first, we need to find the DF. I'm sorry, the confidence interval. So we need to find the DF. So the DF is 24. So if you will look in our given table a while ago, so we have 24 and 99%. So what is now the value of T? So the point estimate for population mean is 18. So, okay. So the value of T is 2.8 or 2.80 if I'm not mistaken. The S is 1.2 and this is the maximum or the margin of error E. And the, what do you call this? The N is 25. So 1.2 divided by the square root of 25 using your calculator, you can type it on your calculator. So 1.2 divided by square root of 25, you will get 0.24. So round off if your answer is too many, so you can still write them all, okay? Or, instead of writing them, you can automatically multiply it to 2.8. So, let's say ganito. 1.2 divided by square root of 25 equals. Then, times 2.8. Then, click equals. And then, for your final answer, it should be 2 decimal places. So, we have 0.67. So, the margin of error is 0.67. Okay? Sometimes you hear this margin of error in the news, di ba? Kapag may mga balita, no? Yung mga, halimbawa, yung Pulse Asia, ganyan, di ba? Sasabihin, with the margin of error of 0.67, ganon. 50% ng mga Pinoy ang sang-ayon kay President Duterte, something like that. Di ba? Sinasabi yun sa TV. Okay. Now, with a confidence interval, okay, so we have this mu. Just like what I've said, this is just like the margin of error. So, kahit hindi na natin ilagay itong mahabang formula na to, ganun din ang lalabas because we have 0.67 as our answer, right? Tignan nyo. Ito yan. Diba? So, ito yung mga answer natin. And then, our mean is 18. So, we will just put 18 minus 0.67 to 18 plus 0.67. So, our answer is 17.33 to 18.63. So, yun ang ibig sabihin nun is meron siyang confidence interval. May interval siya na 17.33 to 18.67. Yung, ano yung problem? Yung mean age, no, of all the entering mathematics major. Yung interval ng age nila, yung edad nila, merong interval sila na 17.33 to 18.67 years old. Or simply, the population mean is greater than 17.33, tama? 17.33 but less than 18.67. Okay, sorry for my writing kasi gumagamit lang ako ng PowerPoint. Okay, so that's all about for the topic margin of error and confidence interval when the population sigma is unknown. Thank you very much for your listening.